All right, so let's take a look at 4.4 part 2. We're going to solve these equations. And again, I take care of what is outside that exponent. I'm going to subtract 2 on both sides first. And then to get rid of my 3/4 exponent, the inverse of that would be a 4/3 exponent. Basically, I do the reciprocal of that fraction. So I'm going to do this on both sides, like the entire side is raised to the 4/3, and this entire side is to the 4/3 as well. So my 4/3 and 3/4, I multiply those and get an exponent of 1, which means I just have a 2x. All right, 8 to the 4/3 though. That basically means the thirds here, that's a cube root of 8, which is 2. And then the 4, I raise it to the 4th. It's basically telling me to do 2 to the 4th. All right, so 2 to the 4th is 16. And then if I divide by 2 on both sides, looks like I got an 8, which I still suggest that we plug that number back into the original and to check our answer is 2 times 8, so 16 to the 3/4 plus 2, does that equal a 10? And yes, it does, so I can check my answer and make sure that we are right. I'm not going to do that on every problem, but I still think that that is the best way for you guys to do for your homework. On number 2, I actually don't have anything outside of the parentheses to take care of. I really have to take care of that exponent first. So the opposite of a 1/2 exponent is, again, it's reciprocal. Instead of 1/2, a 2/1, which is my nice pretty whole number. It's like squaring both sides. So my exponents there, 1/2 and 2, those are gone. I'm left with the x plus 30 equals an x squared. Now, because it's an x squared, I do need to move everything over to the same side. I'm going to subtract my x on both sides, subtract my 30 on both sides. I want this all equal to 0. All right, so what multiplies to be 30, negative 30, and adds up to -1? I'm thinking a -6 and a +5. Multiply to be -30, add up to -1, and I need the x on both of those. So if I set them each individually equal to 0, I'm going to get a +6 minus 6 is 0, and a -5 plus 5 is 0. Okay, so then again, it looks like I have 2 solutions, but I would check them and make sure. So take this. Again, a reminder for part 1, 4.4 part 1, there was a possibility of having an extraneous solution. That's an extra reason why to check your answer. So let's see, if I check my answer on number 1, it was a 2 times x, which in my case would be a 2 times 8 to the 3/4 exponent. Okay, so that was an 8, and then plus 2 gave me the 10. So yeah, on number 1, that totally works. Number 2, let's check this guy. I'm going to check them one at a time. I'll check the 6 first. So 6 plus 30 raised to the 1/2, which, like I said, you can really just do that as a square root. It's the same thing as a 1/2 exponent. So does that equal the x? Does that equal straight up 6? Yes, it does. Okay, so the 6 worked. And we're going to try this again with the -5. So -5 plus 30. And again, raised to the 1/2, or in other words, a square root, same thing. Let's see if that equals our x. It should equal the x and -5. It just gave us a +5. So that is actually an extraneous solution. So that answer is out. We had one solution, x equals 6. All right, and on number 3, I do know that a cubed exponent will get rid of a cube root. However, I have to cube like the entire side. I think what's really important to do on number 3 first, I'm going to add that cube root to the other side. So I get the cube root of 2x minus 5 equals the cube root of 8x plus 1. So I'm going to get rid of my cube root with a cubed exponent, like an exponent of 3. Okay, so it actually happens on both sides. Get rid of it on both sides. So I'm left with a 2x minus 5 equals 8x plus 1. So I'm going to put all my x's on the same side. All right, so 8 minus 2 is 6. I got a 6x here. And then I will subtract 1 on both sides. So -5 minus 1 is -6. And I'll divide by 6 on both sides. Looks like I got a -1 for my x. Let's check that answer. If I put that -1 into the original, it is kind of messy, but that's okay. We can do a cube root as a 1/3 exponent. And I'm checking to see if a -1 for my x works. So instead of 2 times x, I've got 2 times -1 minus 5. And like I said, it's a cube root, like it's raised to the 1/3 exponent. Square root was a 1/2 exponent. Okay, so I don't really care how messy that is. All I care is that that minus my other cube root. So I'll do a 1/3 exponent on this guy. There's my 8x, 8 times -1 plus 1. And I need it in a cube root, so I need it to the 1/3. So I'm trying to see if I do that first cube root minus the second cube root, like my original equation there, should equal 0. It did equal 0, so that is a correct solution. All right, so let's go down to this. This one says blank or blank by negative makes an inequality face the something direction. So this is multiplying or dividing, specifically by a negative, makes the inequality face the opposite direction. So we're going to look at some inequalities here. It's not an equal sign, it's an inequality. Greater than, less than, greater than or equal to, less than or equal to. So on number 4, I am going to get rid of the part on the outside of the square root. I'm going to divide by a 3 first. I divided by a positive 3 though. It's if I'm dividing by a negative, that would make me swap the inequality, but I divided by a positive, so the inequality is still facing the same way. I'm going to square both sides to get rid of my square roots. All right, I'll add 1 on both sides. Addition or subtraction, that does not change the inequality. All right, so it looks like x is less than or equal to 17. All right, so as far as checking the answer goes, I can pick some number that is less than or equal to 17. Maybe I'll pick like a, I don't know, 10 or something like that. And I want to plug it into the original and see if it's true. So let's see. There we go. I'm going to test, like I said, like a, I don't know, pick anything less than or equal to 17. I chose a 10, whatever. So if I do a 10 minus 1 in there, so the left side of the equation, this should be less than or equal to 12. Let's see if this is less than or equal to, that gave me a 9. So 9 is less than 12. So that means that they checked our answer here. And I found just one number in that category that works, but it kind of is a good sign that I got the answer right. All right, number 5. Again, I'm going to get rid of what's outside the root first, so I'm going to divide by 4 on both sides first. It is a positive 4, so I did not change which way the inequality is facing. All right, and then I will do the inverse of a cube root. The opposite of cube root is a cubed exponent, so I did a cubed exponent on both sides. 2 cubed is 8, and then I will subtract 1 on both sides. X is greater than 7. So let's pick a number greater than 7. Maybe we'll pick like an 8 or something. And let's check it out. 4 times the cube root of something greater than 7 plus 1. We chose an 8, so 8 plus 1. And it is in a cube root, so like a 1/3 exponent. All right, let's see if that is greater than 8. 8.32, whatever, that is greater than 8, not by much, but it is greater than 8. So that tells me that we got a correct answer here. Okay, so we checked our answer. That worked. And then last one here. Again, I need everything outside the root to be taken care of. I'm going to add my 3 on both sides first. I'm going to divide by 2. I'm dividing by a positive 2, though. It's not a negative, so it does not change the inequality. It's still facing the same way. And then I will square both sides to get rid of my square root. 3 squared is 9. Okay, so to check our answer, let's pick some number greater than or equal to 9. So maybe we'll just pick like a 10 or something. All right, 2 times the square root of x. The x we chose was 10. And then outside of that was a minus 3. Let's see if this is greater than or equal to 3. 3.32, whatever. This is greater than or equal to 3, so that tells me this is correct. All right, there we go.